Hi, this is the Science Chef. Welcome to the sixth part of a series on the 2023 JAMB Preparation. In this video, we'll be solving random questions on the periodic table. If you'd like to watch our first 5 tutorials on this series, especially the last 2 on organic chemistry, check the links in the description. Alright, let's start. Question 1. Use the table above to answer the questions. Which of the following pairs of letters denotes elements containing the same number of electrons in their outermost shells? The keyword here is elements containing the same number of electrons in their outermost shells. So we have group 1 to 8 and we have period 1 to 3 here. Elements in the same group have the same number of valence electrons, while elements in the same period have the same number of shells. They have the same number of electronic shells, right? Since we are asked to identify elements containing the same number of electrons in their outermost shell, so it means that our focus will be on group 1 and group 8, because those are the two groups that contain more than one element. For group 1 we have A and E. A has an atomic number of 1. How do I know that? Because A there, the first element in group 1, or the first element is always hydrogen. Fine. While E is 11, right? E has an atomic number of 11. So you can write this here. A is 1, E is 11. So if you have to write the electronic configuration of A will be just 1. Well, the electronic configuration of E will be 2, 8, 1. No, we are answering this question based on the letters given to us. Yes, we know that A is hydrogen or A is sodium, but our answers must be based on what is given to us or presented to us in the question, right? The letters of the elements given to us in the question. That's what we are using to answer the question. Fine. Okay. Now group 8, we have B and G. B is 2, 1, 2, while G is 18, right? B is 2, G is 18. The electronic configuration of B is 2, while that of G is 2, 8, 8. Now the question says which of the elements contain the same number of electrons in their outermost shell. Now coming to group 1, A has 1 electron, only 1 electron. That's the only electron in the atom, and that's also the only electron in the outermost shell, right? While E has 1 electron in its outermost shell. Good. But coming to group 8, B has only 1 shell, right? And it has 2 electrons in its outermost shell, while G has 3 shells but has 8 electrons in the outermost shell. So from here we can see that it is the elements in group 1, that's A and E, that have the same number of electrons in the outermost shell. So B and G do not have the same number of electrons in the outermost shell, even though they are in the same group. Yes, normal elements in the same group are meant to have the same number of electrons in the outermost shell. But in this case, B here is an exception. This B is an exception. You know that B is helium. The electronic configuration of helium is an exception in the noble gases. So the answer to this question should be A and E. Let's see. C and D are in the same period 2. They have the same number of shells, but different number of electrons in the outermost shell. Let's see. C here will be 4. That's 2, 2. While D would be 6. That's 2, 4. This is 2 and this is 4. They are different, so it cannot be C and D. E and F, same thing. E and F belong to period 3, right? E is 11. They have the same number of shells. That's 2, 8, 1. While F is 17. That's 2, 8, 7. While E has only 1 electron in its outermost shell, F has 7 electrons, so it cannot be E and F. B and G, okay, we've already seen here that B and G are not correct, right? Then A and, is that A and B or B, A and E? It's A and B that they have here. It's not A and B. That ought to be A and E, right? But they typed here A and B. So it is not A and B. It is A and E, right? So there's no answer in this question. The answer should be A and E. That should be the correct answer, A and E. So let's move on to the next question. Question 2. Which of the following statements about rare gases are correct? 1. The outermost shells are fully filled. 2. They are generally unreactive. 3. The outermost shells are fully filled again. 4. They have 1 pair of electrons in the outermost shells. Okay, what are we working with here? Rare gases. Now, rare gases are also known as what? Noble gases. And they belong to what? Group 8, or call it group 0 of the periodic what? Table. And why are they called noble gases? Because they have the completely filled what? Outermost shell. And what are the members of that group? We have helium, we have a neon, we have argon, we have krypton, we have xenon, and we have radon. They may not be orderly, but those are the 6 members of the group. Fine, and they are all gases. That's why they are called noble what? Gases. They are monatomic molecules. In other words, they do not combine with themselves to form molecules. They exist as atoms. They are also what? Colorless what? Gases. They are unreactive. They are unreactive gases, or inert in nature. So, given that their outermost shells are fully filled, yes, they exhibit the duplet, especially helium. Helium exhibits the duplet, while others exhibit the what? The octet configuration, right? Duplet, in the case of helium, it has only 2 electrons in its outermost what? Shell, which makes it completely filled. It is only 1 shell that it has, right? Whereas the other ones that have more than 1 shell have what? 8 electrons in the outermost shell. So they are generally what? Unreactive, yes, that's why they are inert. Then their outermost shells are fully filled. That's a repetition of point 1. So if 1 is correct, then 3 is also what? Correct. Then they have 1 pair of electrons in the outermost shell. That is not correct. They have 1 pair. That's only 2 electrons in the outermost shell. It is only helium that has that. All other ones don't have only 1 pair. They have 4 pairs of electrons in the outermost shell, because they have 8 electrons in the outermost shells. So helium, it is only, I repeat, it's only helium that has 1 pair of electrons in its outermost shell, because it has only 2 electrons, right? While the others have 4 pairs of electrons in their outermost shells. So the answer to this question is 1, 2, and 3 only, and that is C. Question 3. Elements in the same period in the periodic table have the same elements in the same period. That's the key word here. In the periodic table have the same what? Now, elements in the same period, I told you earlier when I was treating question 1 that elements in the same period have the same number of shells, same number of electronic shells, while elements in the same word group have the same number of what? Of valence electrons. Same number of valence electrons, same number of electronic shells. That's period. Fine. Apart from having same number of valence electrons, those in the same group, they also exhibit similar what? Chemical properties. That is why, apart from hydrogen, other group 1 elements behave in similar what? Ways. Group 7 elements behave similarly. Group 8 elements behave in the same way, right? Because they all have the same number of valence electrons. That is to show us that it is the number of valence electrons that determine the chemical properties of elements, right? Then, period. Elements in the same period have the same number of electronic what? Shells. And as you move across the period from left to right, you move away from metallic properties to non-metallic what? Properties, right? So the answer to this question is obviously what? A, which is number of what? Shells. It cannot be atomic, because the arrangement of elements in the periodic table is based on an increasing what? Atomic number. So there's no way elements in the same period can have the same atomic number. If the atomic number of the element does not change, right, it means that the element too has not changed, right? Because it's the atomic number that defines an element. Once the atomic number of an element changes, the element also what? Changes. Let's take, for example, if you move from carbon to nitrogen to oxygen and to fluorine in period 2, right? This period 2, carbon is what? 6, nitrogen is 7, oxygen is what? 8, and fluorine is what? 9. Can you see? The atomic number is changing progressively by 1, right? And as the atomic number changes, the identity of the element also does what? Changes. So it can be atomic number. C, chemical properties. I just told you that the chemical properties of elements is determined by the what? By the number of valence electrons that they have, right? So elements that have the same number of valence electrons always belong to what? The same group. So which means that they exhibit similar chemical properties. So it cannot be what? C. Then physical properties, no, that has nothing to do with the same period. So the answer is what? A. Question 4. The stability of the noble gases is due to the fact that this is straightforward. The noble gases have completely filled outermost shells. They have completely filled outermost shells, right? and because they have completely filled outermost shells, they exhibit the duplet, that's helium, and the octet configuration, that's for the other members of the what noble gases, right? So that gives them their form of what stability. So let's see which option has that, completely filled outermost shell or the duplet or octet configuration. A, have no electrons in the outermost shell, that's not correct. B, they have duplet or octet electron configurations, obviously that's correct. Let's look at C, belong to group 0 of the periodic table, that is not why they are stable, that's not why they are stable. D, they are volatile in nature, that's not why they are stable. They are stable because they have duplet and octet electron configuration, and that is B. Question 5. The higher or larger the electronegativity difference between two elements, the lower the polarity of their interatomic bond, higher the polarity of the interatomic bond, weaker their interatomic bond, and higher the possibility of forming a molecule. First off, what's electronegativity? Now, electronegativity is the tendency or the ability of an atom to attract electrons to itself. The difference in electronegativity is what determines the type of bond that will be what formed between two atoms of elements, be it the same element or different what elements, right? If the difference between the electronegativity of two atoms forming a bond is between 0 to 0.4, then that bond will be non-polar. And for the fact that it is non-polar, it also means that it is what? Covalent in nature, right? If the difference in electronegativity is greater than 0.4, right, but less than 1.7, in other words, if the electronegativity is between 0.4 to 1.7, then to be a polar bond, but it also be what? Covalent, right? So it's polar covalent. Example of polar covalent here is HCl. That's a polar covalent molecule, right? Due to the higher difference in electronegativity of chlorine over what? Hydrogen. A polar covalent molecule here is non-polar covalent molecule, which is chlorine molecule, while a polar covalent is a hydrogen chlorine bond in hydrogen chloride, right? Then if the difference in electronegativity is greater than 1.7, then the bond is likely to be what? Ionic, to be an ionic what? Bond, as seen in the bond between what? Sodium and what? Chlorine, right? Na plus and what? Cl what? Minus, which means that here now there will be a complete transfer of electrons from the metallic atom to the non-metallic what? Atom. Alright, so from what you are seeing here, the large electronegativity difference between two elements, what will happen? The higher the polarity of their interatomic what? Bond. You can see as we move down this illustration, what is happening? The difference in the electronegativity is what? Increasing. And as the difference in electronegativity increases, what's happening to the polarity? The polarity is also what? Increasing. The polarity of the ionic bond is far higher or stronger than that of the what? The polar covalent what? Bond, right? And that of the polar covalent bond is stronger than the non-polar covalent what? Bond. So the answer to the question is B. Question 6. Elements in the periodic table are arranged in the order of their, obviously the answer is what? Atomic numbers, according to the periodic what? Law, right? That the properties of elements is a periodic function of the atomic what? Numbers. Remember, that was the mistake Mendeleev made in his own table, because he arranged them in order of atomic masses or mass numbers. Why was he wrong? Because you can have elements that have the same atomic masses or the same mass numbers, right? Something like argon 40 and calcium 40. So which of them would you place first on the periodic table if you were to arrange them based on mass numbers or atomic masses? But with the atomic numbers, no two elements can have the same atomic numbers. Are we together? So the best criterion for arranging elements in the periodic table is in the order of their increasing atomic, which in this case is option D. Question 7. Group 1 elements ionize very readily to form positive ions by. Now, this is more of group chemistry. What's the name given to group 1 elements? Group 1 elements are called what? Alkali what? Metals. Why are they called alkali metals? Because they dissolve in water to form alkaline solutions and liberate what? Hydrogen in the process. While group 2 are what? Alkaline earth metals. Group 1 and 2 elements are all what? Metals. Now, another group is what? Group 7. Group 7 elements are known as what? Halogens. That is what? Salt formers. Halogens mean salt formers. Why are they called salt formers? Because they are very reactive in nature. So they combine with metals to form salts. They combine readily with metals to form salts. That's why they are called salt formers. Then group 8 or group 0, which we've already studied or learnt about, are called what? Noble gases. So those are the major groups on the periodic table with family names. For group 1, they are the most reactive metals on the periodic table, and their reactivity increases down the group. The members of the group are lithium, sodium, potassium, rubidium, cesium, and of course francium. Francium is radioactive. It has not been what? Isolated, right? So their reactivity increases down the group. That cesium here is meant to be what? The most reactive. I told you that francium is radioactive. It's not stable. It's not isolated. So we always use cesium as the benchmark, as the most reactive what? Group 1 element. While lithium is the least reactive. And they react vigorously in what? Water. In an exothermic what? Reaction to liberate what? Hydrogen gas. And because they are metals, they ionize by loss of one electron. Why? Because all of them have one valence electron. Let's take sodium and potassium as examples. They will lose one electron each from the outermost shells to form positive univalent ions. This one is 281. This one is 2881. So after losing the electrons, this becomes 28, while this one becomes 288. So you can see they behave in similar ways. So group 1 elements ionize very readily to form positive ions by donating electrons. They are very good electron donors. They are not just electron donors, they are also what? Very good reducing what? Agents, because they lose electrons easily. So the correct answer is what? B. Question 8. Which of the letters indicates elements which exist as diatomic gases? On the periodic table, the major elements that exist as diatomic molecules are the halogens. That's the group 7. But not all of them are gases. In group 7, we have fluorine, chlorine, bromine, and what? Iodine. These two are gases, while this one is a liquid. This is a what? Solid. But all of them are what? Diatomic in nature. So, since we are talking about gases, obviously these two will not be what? There. And this one is in period 4, yes. While this one is in what? Period 5. But what we have in your syllabus ends at period 3, right? So what we have here stops at period 3. Chlorine is in period 3, fluorine is in period 2, right? So it's very likely that F here is what? Chlorine. Are they the only diatomic gases? No. We have other diatomic molecules that are not in group 7. Those are what? Oxygen, nitrogen, and what? Hydrogen. Oxygen, nitrogen, and what? Hydrogen. And all these ones are what? They are all gases, right? So based on this question now, oxygen is in what? Oxygen is in group 6. Group 6. This one is in group 7. No, sorry, this one is in group 5. This is in group 5. Well, this is group 1. Well, supposedly what? Group 1. Fine. So you're now asked which of the letters indicates elements which exist as diatomic what? Gases. So we found one, which is group 7. Is there anyone in group 5? None. Anyone in group 6? None. Okay, group 1. Yes. That's this. That's A there. So our answer is what? A and F. That's hydrogen and what? Chlorine. So the correct option is what? Option D. A and F. Question 9. Electron affinity deals with the... Fine. What's electron affinity? Electron affinity is the energy released when 1 mole of electron is added to a gaseous atom to form a gaseous negative what? Ion. It can be represented thus: X gas plus electron to give us what? X minus gas. Delta HEA is what? Negative. It's mostly associated with what? Non-metals. It's mostly associated with non-metals, and it increases across the period. Increases across the period and decreases down the group. So since it has to do with what? Energy release when an electron is what? Added. Therefore the answer here is what? A. That's gain of what? Electrons. So So let's look at other options. B, loss of electrons. No. Ionization energy. What is ionization energy? Ionization energy is the energy required to remove 1 mole of an electron from the outermost shell of a gaseous atom to form a gaseous positive ion. And it is always endothermic because the energy is always what? Absorbed. You need to remove the valence electron from an atom. You need to break the nuclear force of attraction between the nucleus and the outermost what? Shell, right? So that's why you require energy. You need to absorb energy to break that. And it can be represented thus: M gas minus electron, giving us what? M plus gas. Delta H, IE, is what? Positive. If it requires the removal of the first electron, right, the first valence electron, it is called the first ionization energy. The second valence electron is called the second ionization energy. And ionization energy, just like electron affinity, also increases across the period from left to right and decreases down the group. Ionization energy is mostly associated with what? With metals. And there are some factors that affect ionization energy, or the trend of ionization energy on the periodic table. Those factors are: 1, the effective nuclear charge; 2, shielding effect of inner electrons; and 3, what we call the atomic what? Radius. You can say the distance of the outermost shell from the what? Nucleus. These are the 3 factors that affect the variation of ionization energy on the periodic what? Table. Thermal conductivity is a metallic property and it decreases across the period, so it has nothing to do with electron affinity. So the answer is what? A, gain of electrons. Question 10, the last. An electron can be added to a halogen atom to form a halide ion with a halogen atom is in group 7, right? For a fact that it's in group 7, it will have 7 electrons in the outermost shell. No, it has 7 valence electrons. So if the halogen now gains an electron to form a halide ion, right? Let's take chlorine for example. If this is chlorine, this will be 2, 8, 7. This guy will be what? 17, right? By the time it gains 1 electron, it becomes what? 18, but minus. So it becomes 2, 8, 8. If it is fluorine, it will be what? 9, right? That's 2, 7 plus an electron to give us what? 10 x minus. That's 2 what? 8. So what happens? Their number of valence electrons will change from what? 7 to what? 8. 7 to 8. By the time they gain an electron to form the halide ion, the number of valence electrons changes from what? 7 to 8. So an electron can be added to a halogen atom to form a halide ion with how many electrons? 8 valence electrons, which is why option A is correct. This brings us to the end of our tutorial for today. If you have learned anything about periodic table from this tutorial, drop your comments, hit the like buttons, and subscribe to this channel. Because in our next tutorial, I'll be answering more questions on periodic table. So you need to turn on your notification bell to stay updated when we upload that video. If you have any question to ask, feel free to drop it in the comment section, and rest assured we'll attend to it sooner than you think. Until then, keep moving and don't stop until I see you when I'll see you.